Discuss about the topic photoelectric effect. CBSE, ICSE class 12 physics syllabus covered this topic. By definition, it is that the phenomenon of emission of electron from the metal surface on incident of suitable frequency of light of suitable frequency is called photoelectric effect. What does it mean? We know that there are a lot of free electrons in the metal. These electrons can easily move within the metal surface, but they cannot come out from the metal surface. Due to these free electrons, metals have good electrical conductivity of electricity. Okay, good conductor of electricity. But these electrons cannot come out from the metal surface. It requires some energy to come out from the metal surface. The phenomenon of coming out of electrons from the metal surface on incident of light of suitable frequency, that phenomenon is called photoelectric effect. Okay. The minimum amount of energy to require to come out this electron from the metal surface is called work function. Work function of the metal. Okay. A work function is measured, it is energy, and it is measured in electron volt unit. Unit is electron volt. What does electron volt? When one single electron moving from potential difference of 1 volt, it is called, the energy required is called electron volt. Work function is the amount of energy, minimum amount of energy of the free electrons coming out from the metal surface. It is called work function. It is it is measured in electron volt. This is the experimental arrangement to detect or measure the photocurrent. Photocurrent means the current flowing due to the emission of electron on incident of light. Okay, that means the photocurrent is the current due to photoelectric effect. Okay, this is the experimental arrangement. The red portion is the photosensitive plate, and this is the incident ray of suitable frequency. For a particular metal, there will be a particular frequency of light required. Okay. These photosensitive metals, when there is incident of light, the electrons will come out and moving towards the another plate, and in this circuit there will be a measurement of current, photoelectric current. Okay. Now if we measure the effect of intensity of light, the graphical representation. If we measure from this experimental arrangement or for the experiment, photocurrent and intensity of light. From this experiment, if we measure the photocurrent versus intensity of light, as you know, if we plot graphically X parameter is independent always and Y parameter is dependent. Y parameter is always dependent or a function of X. Okay. If we go on increasing the intensity of light, we will find that photocurrent also will increase in this linearly. Okay. So this is the graphical representation of photocurrent versus intensity of light. From this experimental arrangement or experiment, we will draw four graphical representation of four parameters. Four graphs will be drawn from this experimental arrangement, and after that we will conclusion on a theory, dual nature of light. Okay. Now second graph is effect of potential on photoelectric photocurrent. The X parameter, collector current potential. This is the collector of the electrons. Okay, and it is photocurrent along y axis. I1, I2, I3, three different intensity of light it's falling on the photosensitive plate. Now this is the retarding potential. Retarding potential will be given in this plate to stop the electrons only for experimental purpose. This is called the stopping potential. If electrons are coming, when electrons are coming and moving towards this plate, if negative voltage is given, what shall it will repelled by this plate. Okay, and when suitable amount of negative potential will be given to this plate due to repulsion, once it will come to a stop, and this is that amount of potential, negative potential on the plate. It will be collector plate. It will be called the stopping potential. Here I1, I2, I3 is the intensity of the incident light. I3 is greater than I2 is greater than I1. There will be a saturation in this portion when positive charge is given on the plate. That means the number of saturation, when the saturation portion will come, the number of electrons when collected by the plate, all the emitted electrons will be collected by the collector plate, and so when intensity is higher, so number of emitted electron will be higher, and the plate current, saturated plate current is also higher for I3 greater than I2 greater than I1. Okay. Plot, discuss, and the third graph, that is photocurrent versus collector plate potential. This one. This time different light of different frequency, nu1, nu2, nu3, three different frequency will fall, will be given on the photo plate of same intensity. For same intensity, all the light, the saturation photo current will be same. Okay, and but the stopping potential here for different frequency will be different. Nu1, Nu2, Nu3, different frequency, the stopping potential will be different. Nu3, it is the highest frequency given to the plate, so stopping potential will be highest, and in this way Nu3 will be greater than Nu2, then greater than Nu1. Now discuss the fourth graph, then we will draw the conclusion. This is the fourth graph, stopping potential versus frequency of incident radiation. Here two metals are taken. Here metal A and next experiment metal B. In this graph, here frequency has changed, different frequency of light wave incident, and here the metal will be changed, metal A, metal B. You can see the stopping potential versus frequency of incident radiation. It is different for different metal. Okay, that means the work function or the stopping potential, it depends on the frequency of the incident light. No photoelectric emission is possible for metal A, a frequency less than nu0. For metal B, no photocurrent will be available, will be found, the frequency of incident light less than nu0. Okay, this is called threshold frequency or cutoff frequency. Nu0 is the cutoff frequency for metal A, nu0 prime is cutoff frequency of the metal B. If nu0 is given on the metal B, no light will come out. You can see in the graph that nu0 prime is greater than nu0. Okay, so in metal B, minimum nu0 prime frequency is required, otherwise light emission will not be possible. Nu0 is given on metal B, then no light will come out. But you can see nu0 prime is greater than nu0. So if nu0 prime is given on metal A, then light emission is possible. Nu0 is called threshold frequency for metal A. Nu0 prime is called the threshold frequency or cutoff frequency is cutoff frequency of metal B. Okay. If incident light less than nu0 for metal A, less than nu0 for metal A, and if we go on increasing the intensity of light, still there will be no emission of photocurrent. Okay, so emission of photoelectrons completely depends on the frequency of the incident light. These four graphs describe the photoelectric effect. Okay, now we are going to draw the conclusion of this photoelectric effect. We can see from this graph, I am repeating the conclusion that photocurrent, that is the emission of electron, the emission of electrons does not depend on the intensity of light. It depends on the frequency of the light. Okay, the frequency of the incident light, not the intensity of the light. Now if we are going to from wave theory of light, we know that intensity is proportional to the amplitude of the incident light. Okay, so we can say intensity is greater, intensity is proportional to amplitude square or we can say intensity is proportional to energy of the incident light. Higher amount of energy when will fall on the photo on the electron of the metal, so it should come out. But here this theory cannot explain the phenomenon. Here a suitable frequency of light, only for that electron will come, whatever the intensity of the incident light. For suitable frequency, higher the intensity, higher amount of photocurrent will get. But if the frequency is less, then it will not be possible to get photocurrent. This is the difference. Light cannot explain the photoelectric effect. Okay. Then it is concluded that electromagnetic wave, it shows dual nature. Dual nature means wave nature. There are a lot of explanation of wave nature, or proof of wave nature, that is you can see diffraction, interference, polarization, all are the wave nature of electromagnetic wave. Light, light is one of the electromagnetic wave. It describe all these phenomena, but wave nature of light cannot describe photoelectric effect. From this Einstein theory it comes, it is energy is equal to h nu, and the particle nature of light, it can explain, and that, and comes the concept of photons. Okay, it will explain the photoelectric effect. What I am just in this video, I am just summarizing the phenomenon, that is particle nature of light. That is what Einstein theory, according to Einstein theory, that is any radiation, it is energy is coming out in the form of photons. That is photon is a, that is massless, chargeless particle. Energy is coming in the form of bundle of energy, bundle of particle, and this bundle of particles of photon, when collides with the electron, then it will be the electron of suitable frequency. Here energy, you can see, is equal to h nu from Einstein theory, and the frequency is dependent on the energy of incident radiation. Okay, I will carry it or explain it more clearly in my next video, dual nature of light.